Hello, so before I can start, I have to finish something real quick, sorry for that. Okay, just like that, and now let's run the tests real quick. Okay, so this will take a while, so I guess I have time to do the talk now. Oh, that was the wrong command. The right one is, of course, Cypress run. Not like that, like that. Okay, so this will take some time, and we have time to do this talk. Okay, my talk is about testing tools, mainly about Vitest and Cypress. But this talk is even more about how we can be independent of particular tools and how we can use the best tool for the job and how we can utilize the strengths and weaknesses of particular test frameworks. So the last couple of years, actually, I was renovating my house, and this is actually myself with a sledgehammer. And I learned a thing or two about tools and about that the same task can be tremendously more effective when you use the right tool for the job or if you have the correct tool at all. And on the opposite, if you don't have the best tool for the job, then the same task can take a lot longer. Actually, it should be a video, but for some reason it's not playing. And by the way, yesterday I overheard that somebody from Einhell is here, I think. So this is an Einhell sledgehammer. It's very good. But yeah, that's just as a side note. Okay, so when it comes to testing, we also have a lot of tools. There is Cypress, and we also already heard about Playwright today from Debbie. And a slightly newer tool is Vitest. And also when it comes to testing tools, I think it's very important to know about the strengths and weaknesses of those tools and when we should use which tool and how we can use the strengths of a particular tool for a particular task. So before we dive deeper, a couple of words about important features of test frameworks, at least in my opinion. And maybe a little bit surprising is the first one, it's fast feedback. So in my opinion, the most important aspect of testing is to get fast feedback whether our code that we just wrote works or if the code we wrote a couple of weeks ago still works. So I think fast feedback loops are really very, very important. And the second point I think is more obvious. It's like, why do we write tests? Because we want to make sure that our applications work, that the code we write works, and we want to be confident in our tests that whenever our tests pass, then we are safe to release a new feature to production. So high confidence is also very important. And the third point here on this slide is flexibility. And this is probably one of the least obvious ones. But in my opinion, it's often overlooked. Like, what do I mean with flexibility? First of all, so I mean two things. First of all, we want to be flexible whenever a new tool arrives. So for the last couple of years, we always used Jest to write unit tests and component tests, for example. But recently, a couple of months ago, Vitest was released, for example, and we want to be flexible and always use the best tool or the fastest tool when a better tool arrives. And the second aspect of flexibility is that we also want to use the best tool for whatever use case we currently have. So, for example, if we want to have fast feedback, we want to use a fast tool. And if we want to be confident that our application works in real browsers and that the application as a whole works, then we want to have a tool that gives us that confidence. Okay, so to demonstrate my point, I want to tell a story of two teams. So let's call the first team end-to-end testing. And might be surprising, but team end-to-end testing decides to write mostly end-to-end tests. And they use Cypress for that. And Cypress, for those of you who don't know, Cypress is a tool basically pretty similar to Playwright, what we saw in the morning. And it's a tool we can use to run real tests, or to run tests in a real browser, pretty much the same way as a user would use our application. And the second team, let's call it team component testing, and they mostly write component tests. And it's good that Debbie had her talk in the morning, because I think I don't need to go into much detail what component tests are. Basically, they use Vitest to test particular components in isolation. But let's start with team end-to-end testing. So, as I said, team end-to-end testing, they use Cypress, and they write tests that run in a real browser, and they write tests that are written from the perspective of a real user. So we're clicking real buttons, and we test the whole application as a whole. A typical test that team end-to-end testing is writing looks something like this. So it's a lot more terse than what we saw in the morning, but I think it fits well on a slide. So in the first line, we specify what we want to test. So in this case, we want to test that it's possible to add a new item to a list. Imagine, so that the actual example is a shopping list, but imagine something like a to-do list or something like that. And in line 2, we visit the homepage. In this case, this feature is located on the homepage, but the important thing here is we visit the real page in a real browser. And in the next line, we find an element by label text, so an input field, for example, with the label of title, and we enter some text, in this case, foobar. And in line 4, we find an element by role, in this case, a button, with a specific name, in this case, add item, and we click it. So those find by label text and find by role, those selectors come from a library that's called testing library, which usually comes more from the React world, but more and more it is used for other frameworks as well, and there are plugins for Cypress and Jest and so on. And the important aspect of find by label text and find by role is that way we basically are forced to use accessible elements. Like with find by label text, we are forced to provide a label for our input field, and with find by role, we are forced to use the button HTML element so that this test works. And in the last line, we want to make sure that whatever we are testing actually works. In this case, like I said, we add a new item to a shopping list, so we want to make sure that this foobar text we previously entered appears on the shopping list. So let's take a short look at a real-world demo, how this looks in Cypress. So I already started Cypress, and I can run all the tests, and you see, or you almost not see because it's so fast, but you see that all the features are actually clicked through like a real user would do this, and this is our demo application here. So I can enter something here, click add item, then it's here in the list in this shopping list, and I can click it again, and it's in the recently used list. And if I open this test we just saw, we can see we can hover over all the steps, and that is what it makes really what Cypress really makes stand out, because it's very easy to debug features. Like in this case, we see the visit step, then we see the find by label text step, so where the input field is selected. We see when the stuff is entered in this field. Then here we have this find by role step, and also the click action, and we see exactly where we click. So if our test is flaky, for example, oftentimes the reason is that some overlay or something is in front of the button we want to click. And with this debugging feature, it's very easy to find stuff like that out. Okay, so team end-to-end testing writes a lot of end-to-end tests, and with Cypress, and they are really happy at the beginning because they have a great user interface, as we just saw, and at least at the beginning, the tests are also reasonably fast, but the application is growing. They write a lot of tests, which is a good thing, But if you write a lot of tests, at some point you end up with a lot of tests. And a problem arises. So the more tests they have, the slower the feedback gets. And at this point, I have to make a confession. In the beginning, I was not really working on something, but I'm in team end-to-end testing. And the tests I started are those. So here are 1,540 tests that are running in the background. And they run for some time already now, and they still will be running when I have finished the talk. So feedback is not really that fast anymore, I think. So that's really a problem. And this is where team end-to-end testing is standing now. They have a fantastic user interface because Cypress is really, really awesome in this regard. They can debug breaking flaky tests very easily because they always can open the user interface and make sure or see what is happening. Also, they have very high confidence in their tests because the tests run in a real browser, and they can run the tests in different browsers if they want, and they test the whole application. So not only single components in isolation, but actually the whole application, and they test it in a way like real users would use the application. And so every time their tests pass, which takes a while, but still, every time the tests pass, they are very confident that their application is actually still working. But as we just saw, feedback is getting really, really slow the more tests you write. Okay, but how is team component testing doing in the meanwhile? So team component testing writes mostly component tests using Vitest. And Vitest, for those of you who don't know yet, you should definitely check it out as soon as possible. It's basically similar from the API. It's similar to Jest. So it's a test for writing unit tests, but also for writing tests for Vue components or all other kinds of components, also React components and everything. But it's very, very fast, because the main difference between using something like Cypress or even Playwright and using Vitest to write your component tests is that with Vitest, by default, we don't run our tests in a real browser, but in Node.js with a mocked DOM environment. And this is really, really fast. So it's much, much faster than running our tests in a real browser can ever be. OK, and here we see how a typical test of team component testing looks. So again, we define what we want to test in the first line, and then we see the most important difference. In this case, instead of visiting some page, we render a specific component. So in this case, the shopping list app component, for example. The next step are actually pretty similar. It's just a little bit a different API. But again, we have the find by label text method coming from the testing library, in this case, from the Vue version of the testing library instead of the Cypress version. Again, we find an input field with a specific label and enter some data or some text. And we find a button with a specific name and click this button. And at the end, again, we make sure that a new item was added. So in this case, and if this is the case, then everything works as it should. The test looks actually pretty similar because it's or I made this example, so it's comparable. But usually you might test different things with end-to-end tests and component tests, but this is a whole topic for another talk. The important thing here is that these tests run much, much faster because they don't start the real browser and they don't render the whole application, but just a single component, run the tests in a Node.js environment with a mocked DOM environment, which is very, very fast. But there's also a problem. Although they write a lot of tests and their tests are still very fast, so they have hundreds of tests and still they run in a couple of seconds. So they are happy with that. But sometimes here and there are unexpected bugs in production. So they start to wonder. We have very good line coverage. We have close to 100% line coverage, and we have tests for all of our components. Each component is tested. But still, here and there, we get unexpected bugs, and shouldn't the tests prevent that? They wonder. And the answer is yes and no. The problem with component tests is, here we have an example. We have a parent component which renders a child component. So this is the parent component, and the child, and in the parent component, we listen for an event emitted by the child component. And here we have the child component, which emits an event. And can somebody already spot the problem here, maybe? Very good. You're very good at finding bugs. So the problem here is that here in line 7, we emit a create event, but in line 3, we are listening for a created event. And now, depending on how you set up your component tests, this is an error you might not spot, although you have close to 100% line coverage, because you're always testing components in isolation. So this is one reason among many reasons why if you only rely on component tests, you still can't be sure that everything works in combination or integrated with each other. And then there also is a second problem. So here and there are false negatives. And what do I mean by false negatives? By that I mean that some test is failing, although they are 100% certain that the feature works. So if they test the feature in the browser, they see it working, but the test still fails. And they are not quite sure why, and they have to start to debug, or they have to start debugging and find out why is my test failing, although I know for certain that the feature actually works. And this is actually not that easy to do if you don't have the visual feedback that, for example, Playwright or Cypress is giving you. So if you only have the CLI, you have to work with console logs and stuff like that for problems that you might spot very fast if you had the visual feedback Cypress can offer you. Okay, and this is where team component testing is standing now. So they have blazing fast feedback, as I said. They have close to 100% line coverage because they are very disciplined and write tests for every component they have. And still, everything is very, very fast because Vitest in a Node.js environment is very fast, even if you have hundreds of tests. So, and with very fast, I mean you get feedback in seconds. But there are unexpected bugs because they only test components in isolation and not the whole component, not the whole application as a whole. And there are false negatives which are very hard to debug if they occur, because they don't have the visual feedback. So how can we get around this? How can we eat the cake and have it too? How can we have both of the best of both worlds? And the answer is by always using the best tool for the job, and with job I mean the best tool depending on the use case I currently have. So if I want to have fast feedback, because imagine you make a quick refactoring and you want to know, is everything still working? Because sometimes you change something here and somewhere else you don't expect it to break, something breaks. And in this case, you want to have very fast feedback. You don't want to wait minutes or maybe even hours to find out that this little change or this little refactoring you made broke something somewhere completely unrelated to the piece of code you were working on. But how can we do that? And the answer is we can do it. So I now show you that I can run those 1,540 tests in under 20 seconds if I want, just by using the right tools. And by the way, they are still running here. Okay, oh, spoiler. So let's run my benchmark script. Yeah, works. So we already see this is quite a lot faster. Should be, hopefully, under 20 seconds. Let's see. And yeah, 15 seconds or 16 seconds about. And you have to imagine, thank you. You have to imagine we're still running the Cypress tests in parallel. So it's even my record is like 14 seconds or something like that. Okay, so you might now wonder, how does this work? Or are those really the same tests? And I promise you, those are the exact same tests. So I did run the tests on the exact same files. We can see here is this benchmark 24 file, for example, and here we also have this benchmark 23, and so on. So we run the exact same tests, but instead of running them in Cypress, we run them in Vitest. So instead of running them in a real browser, we are running them in a mocked environment in Node.js. But at the same, now you might think, yeah, okay, well, you already told us that Vitest is fast, but now we have the problems of Vitest again. Now we don't have this nice visual feedback. But the way I did it, you cannot have it both. So you still can run the same tests in Cypress, or you can run them in Vitest, so you can choose. And this is what I mean by the right tool for the job, is you can choose regarding the situation you're in. So if you want to know if you broke something because you made some refactoring, you can get the feedback in a couple of seconds by running them in Vitest. But if you want to know if your application works in Firefox, you can run them in Cypress. Or if you want to have the feedback because you have to debug some test, then you also can run Cypress. So you can do both. You can choose. And now I want you to imagine what this would enable you to do. So imagine you have an application and you have tests for every important feature of your application. So you have a couple of hundred tests, and really for features. So don't think about like components, think about features. So you have a feature for your shopping cart, for your checkout process, for example, and every feature is well tested. And whenever you make a change, so whenever you make a quick refactoring because this piece of code, you hate it and you always wanted to change it, but you always feared to change it because you didn't know what would happen. And if you can get feedback in a couple of seconds, then things like that should be very easy to do, because you change something, run the tests, oh, it didn't work, so I have to fix something, for example, or oh, it's more work than I thought because it's also affecting this component over here, which I didn't expect, and stuff like that. So you can really very fast iterate over your code, because the faster the feedback you get from your tools, the faster you can work. And a couple of days ago, Marvin Hagemeister, very German name, by the way, wrote this on Twitter. So he is one of the core maintainers of Preact. So, in my opinion, there are two very important pieces here. So, first of all, he writes about that it makes it much more enjoyable to try out new ideas. And so the important word here is enjoyable. And I think that's what we all want to have at work. We want to enjoy working with our code base. And that's the first important thing here. And the second one is we invested early. So it's an investment to have a good test and have a good test setup, but it pays off very, very well. So sure, you have to invest something at the beginning, but the longer you work on the project, the more dividends it pays over the long run. So how does it work? How is it possible to write tests once and run them in Vitest and also in Cypress? And the answer is, with so many things, by building bridges. So we built a bridge between our tests and our test framework. And in between, there is the bridge, the driver. Let's call it a driver. So here we have an example interface of such a driver. And this test driver specifies all the methods we need for our tests. In this case, it's a very simplified version, of course. So we have this find by label text method, we have the find by role method, we have the find by text method, and we have a goto method. simple as that. And then we have different implementations for our driver. In this case, we have a Cypress implementation, and I have to say, it's very simplified code. But if you want to find out more, on the last slide, there's a link, first of all, to all the slides, and also to a GitHub repository with some working code and with real examples. So in the first line, we implement the test driver that we saw previously. So this means we need to implement all of the methods the test driver specifies. So we have the find by label text method, and in this case, we use the Cypress function of find by label text. So cy find by label text. Then we have find by role, and it's simply, again, a mapping between this find by role interface of the test driver to the implementation of Cypress. And for go-to, we have then cy_visit, which opens the page in a real browser. But the more interesting implementation is probably the Vitest driver. Again, we implement the test driver type or interface. Again, we have the different methods we need to write our tests. In this case, we're using the testing library again, the vuetest implementation of the testing driver. But other than that, it's again simply a mapping to the testing library methods. But the interesting part is the go-to method, I think, because you might already wonder, yeah, okay, all the other stuff is easy, but if we run our tests in Cypress, Cypress is running the whole application in a real browser. How does this work when we don't have a real browser and we don't have a URL and stuff like that? And the answer is we kind of have a URL, basically, because the view router is an abstraction of all the routing stuff that otherwise the browser is doing. But even when running the application in a real browser, we don't use the real routing implementation of the browser, but we use the view router implementation. So we can use this in our tests to, whenever we visit some page, we can push the page in the router and therefore go to the page virtually, and then, so we push the path to the page. So now we are basically on the page, and then we render the root component of our application. So we render the whole application. And again, I have to say this is pseudocode. The real implementation is a little bit more complicated than that, but basically this is the concept, how it works. And now here we see a test, how it would work, or how we would write the same test we saw previously, now with this driver implementation. So the first difference is, again, we specify the description of the text is the same, but at the end, you see we are into the callback function of the test, we're injecting a driver implementation. And this driver implementation now can be the Vitest driver, or it can be the Cypress driver, or if you want to, you can also write the Playwright driver, and then you have a Playwright driver here. The important thing is only that this driver implements all of the methods we specified in our driver type. But other than that, the test does not care. The test does not care if this is Cypress, if this is Vitest, if this is Playwright. No, it's absolutely not important to the test at all. And then we can simply use all the methods on our driver, so we can use the go-to method. And in case the driver is the Cypress implementation, then we go to the real page and open the real page in a real browser. But if this driver is the Vitest implementation, we just push the route into the view router and then render the root component of our application in a virtual DOM, or not in a virtual DOM, in a mocked DOM in Node.js. And then again, we have the same find by label text, find by role, find by text, which we already saw a couple of times now. And now we have it all. We have blazing fast feedback if we need it. If we want to make this quick refactoring and get fast feedback if everything still works, we can simply run our tests with the Vitest driver. And bam, in a couple of seconds, we know if everything works or not. But on the other hand, if we need the user interface, if we want to get visual feedback because there is some bug in our tests we want to debug, then we can use the UI. Or when we write a new test and we want to get the visual feedback, we also can use the UI of Cypress by starting our tests with the Cypress driver. And we also have the high confidence we get from running our tests like a real user would use our application in a real browser, and maybe in different browsers too. Thanks again to running the tests in Cypress. And hopefully, let's see if the test's still running, by the way. Yeah, they're still running. So hopefully, by decoupling their tests from the actual test framework, both teams go in a brighter future and they live happily ever after. Oh, not here, here. So, yeah, that's it. That was my talk about how we can decouple ourselves from our test frameworks and how we can write tests that are fast when we need them and are also give us also the confidence we want when we need it. Yeah, you can check out my Twitter, obviously. You can check out my book. So I'm writing about this topic in much more detail, or about testing as a whole. And you can also check out all the demos you saw, or the code for all the demos on my GitHub repository. It was a pleasure to speak in front of you. Thanks.